All right, here we go. This paper you have, this is the part 2. So the quotient property for radicals says this. If you have two radicals in a fraction, you can place them underneath one radical. This is going to give me the square root of 9x squared because 18 divided by 2 is 9, and x to the 5th over x cubed is x squared. Now, how does this one simplify? 3x, right? That's just 3x. Okay, what about this one? It's a cube root, so I'm going to make it 162y to the 5th over 3y squared. So if you had a calculator, this would give you 54y cubed. Well, the y cubed is a perfect cube, so that's good, but if I have my pink paper or I use a calculator, the cube root of 54 is not a perfect cube. So I'm going to make it 2 times 27, 3 times 9, and 3 times 3. So a 3 comes out, and I'm going to see if we can't do two things at once. That y is going to come out, okay, because it's the cube root of y cubed. I'm hoping we can start doing some mental work. Okay, I have 3 3's, so that comes out as a 3. The cube root of y cubed comes out as y to the 1st, and what's left underneath is that 2. Okay? All right, that's a little bit of the 13 through 16 that you had on the homework. All right, we can rationalize denominators. What that means is get rid of the radical underneath. So in letter A, I'm going to multiply by square root 5 over square root 5. And what that gives me, and I'm going to put an extra step this time to kind of make it obvious. If I multiply by square root 5 over square root 5, down in the bottom, that gives me the square root of 5 squared. Well, the 2 divided by 2 cancels, and it leaves me with a 5. And you did that in Algebra 1, okay? So that's not new. Now, letter B, we're going to take it to the Algebra 2 level. If I multiply by the square root of x, in the top, this is the product property we learned about yesterday. For radicals, that's the square root of 5x. But down in the bottom, the square root of x squared, 2 divided by 2, is 1, and it's x to the 1st. Okay? I multiplied by square root x over square root x. So square root x times square root x is square root x squared. And do you remember on the marker boards? 2 divided by the root becomes 1, and it just comes out, just like we had been doing. Now, in letter C, what I want to do is I want to put this underneath the same radical first and reduce it. I do not want to multiply by the square root of 12y squared because that's going to make life complicated. It's allowable. You actually can do it, but it'll make your life really rough. So I'm going to simplify. 10 can divide by 2, so that's a 5. The x doesn't do anything. Y cubed over y squared is y, and the 12 divided by 2 is 6. So what I did is all I'm doing is reducing the fraction underneath the radical.
Why'd you bring that? Oh.
Okay, so 10 over 12 is 5 over 6. I did nothing to the x. And then y cubed over y squared is 3 minus 2 is 1. So now I'm going to split it again and make it the square root of 5xy over the square root of 6. This is way easier, way simpler than the original problem. Then I'm going to multiply by the square root of 6. So that's going to give me the square root of 30xy over, now do you remember square root 6 times square root 6 is square root 36, which is 6. Yeah, kind of tough there.
I'm just confused at whenever you went 5xy over 6, where did the y squared go?
y cubed divided by y squared, you subtract the powers. And if you're doing the coloring page, it's y to the first. No, it's okay. Ask. That's what you should do. Okay, now in letter D, the 3 is not under the radical, so I can't cancel it with the 18. So now here's a beautiful connection to what we did yesterday. The square root of 18x squared y, I know how to simplify that. Right? You do. So this is 2 times 9, which is 3 times 3. So the 18 would give me 3 square root 2. Okay, so this is really neat, and we're going to push it together with what we're learning today. Now, what are you going to do with the x squared y?
3x, 2y.
You got it. Okay, so this is going to go 3, the square root of x squared is x, and underneath will be the 2y. Good job, okay? Now the 3's cancel, right? So it's going to be 1 over x square root 2y. Because numbers on the outside can reduce, numbers underneath a radical can reduce, but you can't reduce outside with inside. All right, now, rationalize the denominator means no radical down in the bottom. So I'm going to multiply by the radical. So it's going to be the radical 2y. So the nice thing is, when it's a square root, okay, when it's a square root, you just multiply by itself, as long as it's been simplified. So this is the square root of 2y, and I'm going to write it down so you guys can then catch me. Okay, so up in the top, I get just square root 2y, but down in the bottom, do you remember? Square root 5 times square root 5 is 5. Square root x times square root x is x. Square root 6 times square root 6 is 6. So when I take square root 2y times square root 2y, it's 2y. And 2y times x would be 2xy. When you're ready, let's flip it. And tomorrow we'll do some marker board practice to kind of help this gel. All right, example 7. Letter A. Now we're going to look at other roots. So if I have 2 over the cube root of 3. Now watch me on this one and let's see if this won't make a little bit of sense. I'm not going to multiply by the cube root of 3. Oops, I have them up here. Okay, I'm going to multiply by the cube root of 3 squared. So watch what happens. This is 2 times the cube root of 9, okay, because 3 squared is 9. And then down in the bottom, okay, down in the bottom, when I take the cube root of 3 times the cube root of 3 squared, do you see that that's the cube root of 3 cubed? Because 3 to the first times 3 to the second is 3 to the third. Now, what is the cube root of 3 cubed? It's 3, right?
How did you get
3 divided by 3 is 1, so it makes it 3 to the 1.
I know, but how did you get 3 to 3?
Okay, so when I have the cube root of 3 to the first, I know that when I want it to be a perfect cube, it's got to be to a multiple of 3 power. So I know this exponent property, a to the m times a to the n is a to the m plus n. You learned that in Algebra 1, and we reviewed it at the beginning of this week.
You get 1 plus 2.
1 plus 2 is going to give me the 3, and the goal is I want it to be a 3. Okay? So that's my final answer. Not pretty, but that's it. So look at letter B, 5 over the cube root of x. So I'm going to multiply by the cube root of x squared. And the reason why is I have x to the first, and I need it to be a 3. So the exponent property says we add the exponent. So I need 1 plus 2.
So you did the square. Do you always do that for all of them?
Well, stay with me, and we'll see. So this is going to give me 5 cube root x squared over x, because the cube root of x cubed is x to the first. So the question is, do you always multiply by it to the second power? And the answer is no. What you're trying to do is you're trying to get it to a third power. So look at letter C. If I have 2x over the cube root of x squared.
Can you slow down?
Oh, sure. Yeah, sorry. Okay. So what do I need to multiply x squared by that would give me an x cubed? I don't need x squared because x squared times x squared is x to the fourth. That's too much. Just x. Okay? So you're trying to multiply by something that with the exponents you're actually adding. It's like you're multiplying but you're adding the exponents. So this is 2x cube root x. Now, I'm afraid to suggest this, but I'd like us to skip a step. This is going to be the cube root of x cubed, which is x.
So basically, you're just trying to get the thing that's on the bottom alone, just by like just one thing, not like there not be any exponents or anything, right?
You're trying to get it to not have a radical.
That's what I meant.
Yes. Now these x's cancel, so that's 2 times the cube root of x. All right, letter D, and we'll do this one and then stop. So I'm going to reduce it. I'm going to get x to the fourth over 8y z cubed. And I want to see if you can tell, what did I do? Can anybody tell? What did I do here? Where did the 4 go and the 32 go? Penny? I just reduced the fraction. I said 4 goes into 32 8 times, so I just reduced. So now watch this.
Or you just plug it in and it gives you 1/8.
Yes. So I'm going to separate it now. The cube root of x to the fourth over the cube root of 8y z cubed. Now this connects to what we did yesterday. We're going to simplify the top radical, and we're going to simplify the bottom radical before we try to rationalize. Okay? So up in the top, do you see that I can break this into the cube root of x cubed times the cube root of x? Okay, I'm just splitting the top using the product property. Down in the bottom, I'm going to make this the cube root of 8z cubed times the cube root of y. So what I'm doing is I'm simplifying the top, that's called the numerator of the fraction, and I'm simplifying the bottom, or the denominator of the fraction. So now this is x cube root x over 2z cube root y. Do you see what I've done? I just simplified it into my perfect cubes, and my not perfect cubes. Now, I can't leave a radical in the denominator. In math, that's considered unsimplified. So I'm going to multiply by the cube root of y squared. Why did I multiply by the cube root of y squared? What does that do for us? It makes it a y cubed. So this is going to be x cube root xy squared over, okay, and I'm going to do 2 things here. The cube root of y to the first times the cube root of y to the second is the cube root of y cubed. The cube root of y cubed is y. So I'm going to make this 2yz. And that's my final answer.
I think it's because you say the word cubed and root and all of it so many times that it's like, what? You can't not do that because that's the words.
That was actually a pretty long problem.
That was